Hello everyone. In this video, I will be discussing some random questions from Form 4 and Form 5 as a revision for SPM at Maths 2024. So let's begin. You can access this question through the Google Drive link that I've given in the description. Please download before seeing this video further. So let's begin with the first question, which is about functions. Okay, so we have a question where diagram 4 shows the relation of three sets, basically x, y, and z. Okay, we have a function that maps x to y, and we have a function that maps z to y. And then we also have a function that maps x to z, which is h, as indicated in diagram 4. So as we read the question, we know that fx is ax plus b and maps x to y. So we can immediately go and label the diagram given here as f in this particular location. This is function f, and then function gz is mapping z to y, So this is function g. So this is the information that we got after reading the first statement. Now they are requesting us to find the value of a and b. So how to find the value of a and b? Very simple. First, we need to list down the functions given. Okay, I have the first function, which is g of z is equivalent to 5 over 3z minus b. 3z minus b. Okay, so in this function, we only have one unknown, which is b only. The other function, which is fx equivalent to ax plus b, has two unknowns, a and b. So it is always recommended to start with the less number of unknowns. So the best is to start with the function gz. Okay, as we can see, here the object is -2 and the image is 1. So that means g of -2 is equivalent to 1. So let me write down for you. G of -2 is equivalent to 1. So what I need to do, the -2 I need to put into the position of z. So that will make my equation 5 over 3 times -2 minus b equivalent to 1. As I continue, what I need to do, I need to further expand these brackets. So 3 times -2 will be -6, and then minus b is equivalent to 1. And then what I do, this entire denominator, I will bring it up here as a multiplier. So I'll end up getting 5 equivalent to -6 minus b. And then 5 plus 6 is equivalent to negative b, because I shifted the -6 the other side, so it becomes plus 6. So I end up getting negative b. 5 plus 6 equivalent to 11. 11 equals to negative b. So negative b is equivalent to 11, and therefore b is -11. So that is the solution to find b. B is -11 as stated. Okay. Let's continue to find the a in the function. So as you all know, the function fx is given to be ax plus b, and we just got to know that the b is -11, so we can straight away put into the equation. So now we only have one equation, which is the a only. So using the same method, like how I relate the object and image for function g, I'm going to do the same for function f. The object is 4, the image is 1. So into the function f, I'm going to put f of 4 is equivalent to 1. So I'll put into here f of 4 is equivalent to 1. Therefore, I'm going to put the 4 into this particular position. So a multiplied by 4 minus 11 is equivalent to 1. So 4a minus 11 is equivalent to 1. 4a is equivalent to 1 plus 11. Therefore, 4a is equivalent to 12, and a is equivalent to 12 over 4. And finally, a is equivalent to 3. And that will be the answer for part A. So you can just put it here. Okay. So that is part A1, A Roman 1. And let's move on to B Roman 1. Okay. In B Roman 1, what you need to understand is that the function gz, we already updated with the unknown, which is 5 over 3z plus 11. Okay, you have to understand why it is plus is because in the original function it is minus b as stated here. But when you put minus negative 11, the negative and negative will become positive. That is the reason why here it becomes positive 11. Please take note. Okay, now the question for part B Roman 1 is that we need to find the function that maps y to z. That means from y to z. So the arrow goes in the opposite direction. So obviously this is G inverse. G song sang. So if you want to find the G inverse, it's very simple. We're going to make y is equivalent to whatever the function that we have right now. Okay. And then this entire bracket goes up and the y goes down. So it becomes 3z plus 11 is 5 over y. And then our target is to make z subject. So I need to remove the 11. So it becomes 5 over y minus 11. And we can finally conclude that z is equals to 5 over y minus 11 divide by 3 and divide by 3. Okay. As you can observe here, this is actually two different terms. So we are required to make it a single term. So how to make it a single term is very simple. We just need to multiply to make the denominator the same. So multiply by y here, multiply by y here. So you'll end up getting 5 minus 11y over 3y. And finally, we can give the answer for G inverse of z, which is 5 minus 11z over 3z. And that will be the final answer for B1 as stated here. Okay. And whenever you give answer in fraction, a fractional function, you have to mention this particular value. Okay. In this case, I cannot put 0 in the position of z because that will make the function undefined. So always that undefined value you must indicate as a addition to your final answer. Okay, as we go on to B Roman 2, we have to find HX. Okay, so for some students, this may look little complicated, but please do not panic. This is quite simple. What you need to understand here is that, let me clear all this indication. First thing that students need to understand here, this is my domain. Basically, this is my domain, and then it goes through the first function, which is the function h, becomes my codomain number 1, first codomain, and then goes through another function, becomes codomain number 2. So the first function is h, and then the second function is g. Okay, but now can you see this particular function f is straight away from the domain going to the codomain. So this is something like this. We have the first set, second set, and third set. So the first function here is h, and then the second function is g. And this function f is going from here, from the domain, straight to the last codomain. So this is the function f. So basically, we can conclude that function f is the composite of the both function hg, in which we have to write as gh because we are doing the function h first followed by function g. So you cannot write hg, you must write as gh. So please take note of that. So GHX function GHX is actually equivalent to the function fx. So we can make a conclusion that GHX equals to ax plus b, in which it's 3x minus 11. Because the value of a and b we already found out in the previous working. And then we have the function gz, the second function gz, which is 5 over 3z plus 11. Okay, but in order to make our understanding easier, we will actually what we do, we will change this particular z here and here into x to make the understanding easier. So we can just write as gx is equivalent to 5 over 3x plus 11. So in that understanding, what happened, we have GHX is equivalent to 3x minus 11, and we have GX, which is equivalent to 5 over 3x plus 11. So in this case, we just need to find the HX. So this is a very simple composite function. in which we need to find the hx in the middle. So usually for this kind of question, what we will do, we will actually replace the x in this particular equation with hx. So we put h here, automatically here also becomes h. So we can make a conclusion that GHX GHX is equivalent to 5 over 3HX plus 11. Okay, let me write down nicely. Sorry for the trouble. So 5 over 3h. So this is our GHX, and according to the question, 5 over 3HX plus 11 is equivalent to the GX that we have in the diagram is 3x minus 11. So we need to equate them. So 3x minus 11. So as we continue, what we need to do, very simple, because our target is to make hx as a subject. So this entire bracket will go up and this entire bracket will come down. So it will become 5 over 3x minus 11 is equivalent to 3hx plus 11. So 3hx plus 11 is equivalent to 5 over 3x minus 11. Okay, so 3hx will be equivalent to 5 over 3x minus 11 minus 11 over 1, because basically it's just minus 11, but I'm just putting over 1 because my next step is about making the denominator same. So I'll multiply with 3x minus 11 here, and then I'll multiply with 3x minus 11 here. So this particular step will make my my terms, two terms, to become single term. So I'll end up getting 3hx equals to 5 minus 11 bracket 3x minus 11 at the numerator, and at the denominator it becomes just one term, which is 3x minus 11. So 3hx will be equivalent to 5 minus 33x plus 1 to 1 over 3x minus 11. And as we simplify further, 3hx is equals to 5 plus 1 to 1, you'll get 126 minus 33x over 3x minus 11. And 3hx is equivalent to, I think I can factorize 3 here, so I'll factorize 3. So when I factorize 3 here, I realize I'm actually getting 42 minus 11x over 3x minus 11. And finally, when I make hx subject, I just gonna take the 3 and bring it down. So we'll have 3x minus 11 at the bottom. So the 3 that I'm dividing will just come down here as 3. So what will happen in this case, that particular 3 and 3 can be cancelled. And I can conclude that my hx equals to 42 minus 11x over 3x minus 11. So that will be the final answer for your question, Roman 2. And as I mentioned earlier, whenever you get a fractional function, you have to indicate the undefined value. So very simple, take the denominator, put in equal sign and make it equals to 0 and make x subject here. So 3x is not equals to 11 and x is not equals to 11 over 3. And this statement you must write here as your final answer. Okay, so that is the end of hx. And finally, the Roman 3, B Roman 3 is very simple. They're asking us to find the object of hx when the image is negative 2. As you can see, for this function hx, the image is negative 2. So the corresponding object for that function is 4. So for this one, the answer is 4. There is no working. You just need to indicate based on the diagram. So that will be the end of our first question for today. Okay. So let us move on to the next question, which is quadratic functions. Okay, basically for this particular quadratic functions, what we have is we have a alpha beta question. So it's not a very difficult question. We still can do. First, let us read the question. It is given that alpha and beta are the roots of the quadratic equation x open bracket x minus 8 close bracket equivalent to 3h minus 15, such that h is a constant. So with this information, we have to find the range of values of h if alpha and beta are not equal. According to the statement here, alpha and beta are not equal. So what they're trying to say by this statement is that these are two different real roots. So that's what they are trying to say. Because if there is no roots, there is no alpha beta. If alpha is equivalent to beta, that means two equal roots. And since alpha and beta are not equal, there are roots, they are real roots, but both of them are different from each other. So we can make a conclusion for this case is that b square minus 4ac must be greater than 0. And using this discriminant, we're going to find the range of values of h. So that's how we're going to settle this question. So let me do for you part A. So as I expand the equation, I'll get x square minus 8x minus 3h plus 15 equivalent to 0. Okay, and I observe that my A is 1, my B is negative 8, and then my C is whatever remaining, negative 3H plus 15. Some students make mistake, they take only 15 as C. You have to take everything after the X, even though there are more than one terms. Okay, as I explained earlier, I'm going to use B square minus 4AC more than 0 as my basis to answer this question. So I'm going to input all the A, B, C values. So negative 8 square minus 4A, C more than 0. So I'll end up getting 64 plus 12h minus 60 is more than 0. So 64 minus 60, I'll end up getting 4 plus 12h more than 0. So 12h is more than negative 4 and h is more than negative 4 divided by 12. And finally, I'll get h is more than negative 1 over 3. And that should be the range for h as indicated. Okay, please take note, no need to change the direction of the symbol because you are dividing by a positive number. When you divide by a positive number, you no need to change the direction or the symbol of inequality. Okay, so now we're going to move on to the part B of the question. So in part B of the question, they say given alpha over 2 and beta over 2 are the roots of the quadratic equation x square plus kx plus 3 equivalent to 0 such that k is a constant, find the value of h and k. So if you want to find the value of h and k, you have to really understand the question is that for this particular equation, the roots are alpha and beta. And again, using the same alpha and beta, when you divide by 2 and divide by 2, you can form a new equation which is x square plus kx plus 3. So A and B are not two different questions. A and B are one single question with the same alpha and beta. So what I'm going to do as first step, I'm going to write this equation in the proper form. So it's going to be x square minus negative k x plus 3 equivalent to 0. And according to the formula, x square minus sum of roots x plus product of roots equivalent to 0. So in that understanding, we know that sum of roots for this particular equation are alpha over 2 plus beta over 2. So it's going to be alpha plus beta over 2. And when we observe, when we do comparison, the sum of roots are negative k. So I need to put sum of roots is equals to negative k. So this thing will become very important for us to answer our question later on. In order to find the value of k, we need to really use this particular equation that I put into the box. Okay. The second thing, when we go to product of roots, which is alpha over 2 multiplied by beta over 2, we'll end up getting alpha beta over 2. And according to our equation, when I compare, I get product of roots is equivalent to 3. And this also serves as one of the very important information for me to answer the question, the finding h and k. So now we go back to our part A equation, which is x square minus 8x minus 3h plus 15 equivalent to 0. So this is our part A equation, in which here when I compare with x square minus sum of root x plus product of root, I will end up getting the fact that here the sum of roots are alpha plus beta, because for this particular equation, the roots are alpha and beta, not alpha over 2, beta over 2. Only for this equation, the roots are alpha over 2 and beta over 2. Okay, there are two different equations. Please take note. So the sum of roots are alpha plus beta, which when you compare, it is equivalent to 8. So this serves as one of the very important information. What I'm going to do here is that I'm going to take this alpha plus beta and then I'm going to put into this particular position. So when I do that, what will happen? I'll end up getting a substitution that simplifies the entire equation. I'll take this and I'll put into this position. So what will happen? I'll end up getting 8, because alpha plus beta is 8. 8 divided by 2 is negative k. So 4 is equals to negative k, and therefore k is negative 4 as stated. And I'm going to find the h. As I see, the product of root is equivalent to negative 3h plus 15. So the product of root is alpha beta, and it is equivalent to negative 3h plus 15. So how to settle from here? Some student may get confusion, but no need to worry. When you see this particular box that I mentioned earlier, alpha beta over 2 is equivalent to 3. So that means we can make a conclusion that alpha beta is equivalent to 6. Alpha beta is equivalent to 6. So with that alpha beta equivalent to, sorry, not alpha beta over 2. There is a small error here. I'm very sorry about it. It's actually alpha beta over 4, because 2 times 2 is 4. So you cannot put as over 2. I'm really sorry for that mistake. Finally, I found it. I'm very sorry. So it's going to be alpha beta is equivalent to, when you bring the 4 up here, 4 times 3 is 12. So alpha beta is equivalent to 12. So I'm going to use this information put into here. So here alpha beta equals to negative 3h plus 15. So I can make a conclusion that negative 3h plus 15 is equivalent to 12. So negative 3h is equals to 12 minus 15. So negative 3h equals to negative 3. Therefore, h equals to negative 3 divided by negative 3. And finally, h equals to 1. And that should be my answer for h here, as stated. Okay. So I hope my students are clear with the explanation. Please try to follow back. And I'm really sorry about this small error that I finally rectified. Make sure you rectify in your solution also. Okay. So let's move on to indices, search, and logarithm. Okay, in this one, we are requested to express P in terms of Q. So very simple, we have an equation. We just need to replace the values with P and Q. Okay, so let's begin. So we have 5, 2K plus H. So whenever indices are added, that means it is multiplied. So we have to expand and write like this. Okay, 10 plus 25k. But as I know 25 is 5 to the power of 2, so I'll write as 5 to the power of 2, and don't forget the k. So this is going to be my first step. I put a multiply here is because I'm separating the index into two different bases. And then what I'm going to do, this term, I'm going to bring it to the left hand side. So I'll end up getting 5 2k times 5 to the power of h minus 5 to the power of 2k is equivalent to 10. Now what I'm going to do, I'm going to factorize 5 to the power of 2k. So once I factorize from here, what is remaining is 5 to the power of h here. And when I factorize 5 to the power of 2k, what is remaining here is just 1, equivalent to 10. Now I'm going to do all the substitution inside. I'll substitute all the given information into my latest equation here. So 5 to the power of 2k according to the question is equivalent to P, bracket 5 to the power of h is equivalent to Q, and then minus 1 is equivalent to 10. Therefore, P is equals to 10 divided by, bring down the entire bracket of Q minus 1, and that will be the answer as stated. So this is a very simple, straightforward question that can come out for your exam, but the key here is factorization. Please take note. If you don't factorize, you will not be able to summarize as below. Okay, so let me move on to the next one, which is appears to be a little bit complicated for majority of the students, but it's not really that complicated. Let me show you how to solve this easily. Okay, first thing, we are given 16 to the power of x equivalent to layers of surds. We have cert 2, cert 8, and cert 4. So no need to panic. first thing that you need to do here in order to make your life easier is that you have to write that 16 to the power of x is actually equivalent to 2 to the power of 4 x, because 2 to the power of 4 is 16, so you have to replace the 16 with 2 to the power of 4. So first, this is the step. So we're going to write there 2 to the power of 4x is actually equivalent to square root 4, and then square root 8, and then square root 2. So what I'm going to do here is that I'm going to square both sides. So when I square both sides, what will happen? Okay, as you can see, this is the statement. This is the equation that we have right now. We're just gonna apply this square on both sides. So I'll apply square here. I'll apply square here. So when I apply square, this 4x will be multiplied by 2. So it becomes 8x. And then this square and square root will eliminate each other. So I'll end up leaving with 4, square root 8, and square root 2. Remember, when I square, only the outermost square root will disappear. The inside square root will still remain. Please take note. Okay, again, I'll do the same step. 2 to the power of 8x is equivalent to 4 square root 8 square root 2. I'm going to again square both sides. So when I square here, 8x times 2 becomes 16x. And here, please take note, this square will eliminate the square root and also will act as a square for this number. So 4 square will become 16 multiplied by 8. Why multiply by 8? Because the 8 is now a single number without the square root. And then multiply by surd 2 here. Multiply by surd 2. And finally, what happens as you continue? 2 to the power of 16x is actually equivalent to uh, 16 multiplied by 8. Okay, 16 multiplied by 8, you'll end up getting 1 to 8. 1 to 8 multiplied by surd 2. Okay, so here what you can do, very simple. 2 to the power of 16x is equals to 1 to 8, which is 2 to the power of 7. 2 to the power of 7 multiplied by 2 to the power of surd 2. You just leave it as surd 2. And again, you can square. So when you square for the last time, this last process of applying the square is to eliminate the square root, and this times 2, and this also times 2. So it becomes 2 to the power of 32x. This is same procedure, just multiply by these two number. And remember, when you square, the square must go to the square root and also must go to the 7 here. So that will become 14, and here it just becomes 2 only, which is 2 to the power of 1. And finally, we have 2 to the power of 32x equals to 2 to the power of, since there is a multiplier and same base, the 14 and 1 you can add together to become 15. So you already have the more simplified version. So we can make a comparison that 32x equivalent to 15. Therefore, x equals to 15 over 32. And that is the answer as stated. Okay, so this question is important if you ask me, is because it involves a lot of basic algebra knowledge, in which students will forget the fact that when I apply square, only the outermost square root is eliminated. Second thing, when you square with the number outside, remember, when you do a and b square, the square goes for a as a square, and also the square goes for the b as b square. So this is an important concept that majority students overlook when they do the question. So please take note of it. Okay. So now let's move on to another question related to progression. So in this particular question, we have three circles. The circumference of the first circle is 50 cm, and then the circumference of the second circle is 25, and then 25 over 2. Because they said the circumference of each subsequent circle is half of the circumference of its previous one. So if the first one is 50, means divide by 2, you get 25. 25 divided by 2, you get 25 over 2. You can put as 12 over 12.5, but I prefer using fraction. No problem. Okay, determine whether the circles form an arithmetic progression or a geometric progression. Okay, in order to determine whether the circles form an arithmetic or geometric, first we need to find the radius. Because if we want to find the area, we need to know what is the radius. So I'm going to find the radius. So circumference for the first circle C1 is 2 pi R1. Okay, and then 2 pi r1 is equivalent to 50. The circumference of the first circle is 50. Therefore, 2 pi r1 is the radius of the first circle, is equivalent to 50. Therefore, r1 is 50 divided by 2 pi. So R1 will be 25 over pi. Please take note. So the area 1 of the first circle will be pi R1 square. So area 1 will be pi multiplied by R1, which is 25 over pi square. So your area 1 will be pi multiplied by 25 square, which is 625 over pi square. And as you simplify, you'll get area 1 equals to, simplify the pi and pi, is 625 over pi. That is your area 1. So I'm going to do the same procedure for area 2. So area 2, before I find area 2, I need to find my radius 2. So let me find my radius 2. My radius 2 will be 2 pi. R2 is equivalent to 25. Because my circumference of the second circle is 25, so I'm following the same. So my radius 2 will be 25 divided by 2 pi. Okay, and then my area 2 will be pi radius 2 square. So my area 2 will be pi radius 2, which is 25 over 2 pi square. So as I continue, I'll realize that my answer pi multiply with 25 square, which is 625 over 2 pi when you square. Please take note, when you square, you have to square both the top and bottom. 2 pi when you square, you'll get 4 pi square. So as you simplify, you realize this pi and this pi will cancel off. You'll end up getting 625 over 4 pi. That is area 2. And as you continue for area 3, you need to find the radius 3. So 2 pi R3 is equals to the circumference of the third circle, which is 25 over 2. 25 over 2. Therefore, R3 is equals to 25 over 2 divided by 2 pi. So R3 will be 25 over 2 times 1 over 2 pi. So you'll end up getting 25 over 4 pi. So that is the radius of the third circle. So I will find the area 3. So the area 3 will be pi radius 3 square. So it will be pi multiplied by 25 over 4 pi square. Okay, as you can see, it's 25 over 4 pi square. So you will actually end up getting pi multiplied by 625 over 16 pi. 16 pi square. So this pi and the pi will cancel off. You'll end up getting 625 over 16 pi only. So I think this is clearly a geometric progression, but never mind. Let me find the common ratio. Common ratio is term 2 divided by the first term. So the term 2 is 625 over 4 pi divided by the first term, which is 625 over pi. So the common ratio will be 625 over 4 pi multiplied by pi over 625. So as you simplify with this and this, you'll end up getting the common ratio is 1 over 4. But we cannot just stop here. We need to do one more set, which is between term number 3 and term number 2. So as you do that, 625 over 16 pi, which is the area of the third circle, divide by term number 2, which is 625 4 pi. So my common ratio will be 625 over 16 pi multiply. So inverse the fraction. So 4 pi over 625. And as you simplify, you'll get 4 over 16, which is also equivalent to 1 over 4. Therefore, you can make a conclusion. Term number 3 divided by term number 2 is equivalent to term number 2 divided by the first term. And we can make a conclusion. It is a geometric progression. So the answer should be geometric progression. That's why they give this 1 over 4 to indicate that is the R value. So did you show the 1 over 4? Yes, then you are safe. Okay. Now we need to find the sixth circle, area of the sixth circle. That means term number 6. Very simple. In order to find the term number 6, it is AR 6 minus 1. So AR power of 5. The first term is, as per our question, the first term is 6 to 5 over pi multiplied by 1 over 4. The common ratio is 1 over 4 to the power of 5. So as you press this in calculator, what you need to do, 1 divided by 4 to the power of 5 multiplied by 6 to 5. So you'll end up getting 6 to 5 over 1024. Since there is a pi at the denominator, you just replicate the pi. So you end up getting 625 over 1024 pi. And as stated, that is the answer. So with that, we already settled with progression. So my advice to my students is please do not forget to square the denominator and make sure that you you find all the three areas before you make the judgment. Some students, they only find the area of the first circle and second circle, and they'll just stop here. This is not enough, because end of the day, students are required to prove this statement. Then only you can make a conclusion that it's a geometric progression. Okay, so we move to the last topic for today, which is about the integration. So let us look into this. So we will finish within next 10 minutes, hopefully. So here for this question, we have a particular statement: 2k minus integration of fx equals to integration of fx minus 8, blah blah blah, where k, p and q are constants. So we have to express uh, this particular term in terms of k. So how to do this? Very, very simple. Okay, according to the question here, we have 2k minus integration from 2 to 3p minus 1 fx dx is equivalent to integrate from q to 2 fx dx minus 8. Okay, so this is the equation that we have. So what I'm going to do, I'm going to rewrite as integrate from q to 2 fx dx minus 8 is equivalent to 2k minus integrate from 2 to 3p minus 1 fx dx. So what happens, this term, this particular term, which I can show using a different color maybe, this particular term with the negative, I'm gonna move to the right hand side, and this negative 8 I'm gonna move to the this term with the integration I'm gonna move to the left hand side, and this negative 8 I'm gonna move to the right hand side. So I'll end up getting integrate from q to 2 fx dx. Since it is negative, when I shift the other side, it becomes positive. Positive 2 to 3p minus 1 fx dx is equivalent to 2k, and as I mentioned, the negative 8 when you bring the other side becomes positive 8. Okay, so now here the important thing comes in, because as you can see, here and here are the same numbers and the same function, which is fx. We can merge this into one single integral. So q to 3p minus 1 fx dx is equivalent to 2k plus 8. Okay, and that is the answer for the first question, because they ask us to express q to 3p minus 1 fx dx in terms of k, and we already done that, 2k plus 8 as stated. So no problem, as simple as that. So now we are going to move into the second part. The second part may seem complicated for some student, but actually that is not the case. It is not as complicated as it looks. You need to follow a certain rules in order to answer this question. Okay, so it is given that differentiation of 5t minus 4 square is equals to 10 gt. Find integral 1 to m gt gt dt in terms of m such that m is a constant. Okay, so first thing that you need to understand here is that, as per question, differentiate d dt open bracket 5t minus 4 square is equivalent to 10 gt. So before we apply integration, we always have to make sure the dt is sent here as beside the gt. The dt here must always be sent first. So what is remaining here is just d 5t minus 4 square, and then on the other side we have 10 gt dt. So now what happens, you're going to apply the integral sign. You're going to apply the integral sign on both left and right side. So when you apply the integral sign, what happens? The integral and differentiation will cancel off each other. You'll have 5t minus 4 square is equals to integrate 10 gt dt. And that is the step that you need to do for every question similar to this concept. Okay, but the problem is they are not asking for 10 gt dt. They are only asking for gt dt. So the 10 we need to remove. So what happens here? Integrate 10 gt dt is actually equivalent to 5t minus 4 to the power of 2. So this 10 is unnecessary because in our statement we only have gt only, we don't have the 10. So the 10 is actually a constant, we can take it out. So once you take it out, it becomes 10 gt dt is equivalent to 5t minus 4 square. So what happens? Integrate from gt dt is equivalent to 5t minus 4 square, and this 10 will go down as a divider, as a denominator. Now we have what we want. We have the gt dt with the integral sign. We already have. The only problem here, we don't have the limits. So the limit according to the question is 1 to m, right? So just put 1 to m. Here also you just need to put 1 to m. That's all. So with that particular step, you will be able to continue. Integrate from 1 to m. Gt dt is equivalent to 5t minus 4 square divided by 10 with the m. So first you have to put m inside the position of t. So it becomes 5m minus 4 square over 10 for the first iteration, minus for the second one. When you put 1 here, 5 times 1 is 5. 5 minus 4 is 1. So 1 square is 1. 1 over 10. So you need to put 1 over 10. So finally integrate from 1 to m. Gt dt is equals to 5m minus 4 square. So this one, when you expand, you'll get 25 m square minus 40m plus 16 over 10, and you have minus 1 over 10. So you just need to make them into one single term, because here we have two terms. So since the denominator is same, might as well you just gonna bring them together like this. So you'll have plus 16 minus 1 over 10. So in which you'll get 25 m square minus 40m, and this 16 minus 1 become positive 15 over 10. So I think from here onwards you are able to do, because 25 and 10, I think you can factorize maybe 5 from here. So as you factorize 5, you'll end up getting 5m square minus 8m plus 3 over 10. And you can simplify as 2, simplify as 1. So you'll end up getting 5m square minus 8m plus 3 over 2. And finally, you can write them individually. 5 over 2m square, 5 over 2m square, minus 8 divided by 2 is 4m, and plus 3 over 2 as your final answer as stated here. Okay, so please revisit the entire video. It took only about 40 minutes, but a lot of things has been covered in this video. If there is any question that you are not clear, you can just mention the subject. For example, functions or quadratic function, you just say mention. So on this topic, I have a question. Can you please clarify? Please post comments. I will provide another separate explanation video, or I'll reply on the comment itself. Thank you and all the best for your SPM.